Hi all. So let's look at simplifying something a little tougher now, dealing with radicals. So we've got 3 times the fourth root of 243 x to the ninth y to the sixth all over the fourth root of x to the negative third y. Looks kind of intimidating, huh? Well, let's take this 3 and move it off to the side. And then inside the radical here, let's put this whole thing. So I'm going to use the quotient property of radicals here. So I'm going to put this whole fraction 243 x to the ninth y to the sixth over x to the negative third y. Now the effect that's going to have, I'm going to rewrite my 3 here, is I can now reduce that fraction a little bit. So I'll have my 243 here. Now I've got with these x's, I've got like bases getting divided, so that's going to be 9 minus a minus 3, so it's really 9 plus 3, which is 12, so x to the 12th. And then y to the 6th over y, that's going to be y to the 5th. All right, so the fraction's gone. I don't have to worry about that anymore. Now let's rewrite this 3. Now let's look at this 243 for a minute, okay? So 243, if you're not sure what that's all about, turns out it's a perfect fifth power. It's 3 to the 5th. So I'm going to write that as 3 to the 5th power, x to the 12th, y to the 5th. Now something I like to do at this point is, rewrite that 3 again, is pull out or isolate for anything to the, in this case, the 4th power, whatever the index is. So I've got 5 3's. I'm going to pull 4 of those 5 3's off to the side here and multiply that by that last 3. I'm going to do the same thing with that x to the 12th. So basically, in other words, I'm going to say, all right, let's look at this 12. What's the next number lower than 12 that's divisible by 4? Well, hang on. I get ahead of myself. 12 is divisible by 4, so scratch that last thought. So I'm just going to rewrite to x to the 12th. It's the y that I'm after there. Let's look at this y to the 5th. What's the next number down from 5, because 5 is not divisible by 4? What's the next number down from 5 that is divisible by 4? Well, 4 itself is, right? So I'm going to write this as y to the 4th times that y to the 1st power. Okay? So what's happening here is I've got a group of 4 3's that I'll pull out of there, a group of 12 x's that I'll pull out of there, and a group of 4 y's that I'll pull out of there. So, still rewriting that 3 there. I pull that 3 to the 4th out, it becomes a 3. Right? The 4th root of 3 to the 4th is just 3. I'll pull out this x to the 12th out. That's going to be 12 divided by 4 is 3, so x cubed. And then y to the 4th comes out. The 4th root of y to the 4th is just y. I'm not going to mess with those absolute values that I talked about in another video. Let's see, what's that leave us with? The 4th root of 3y. I kind of don't have enough room here. Let me write my answer up here. I'll do it in green. It's going to be 3 times 3, which is 9, x to the cubed power, y, times the 4th root of 3y. And that's how to reduce this particular problem. All right, that's about as hard as it gets for these radicals too, which is plenty hard.